A user terminal, perhaps a keyboard printer, is linked via a communication line and a multiplexer to a host computer. An operator prepares an inquiry from a terminal to an application program. Before transmission to the host, device control and line control are appended. The message then flows to the host, where it's checked for accuracy and validity. Here, the application program processes the data and sends a response to the terminal, where it's printed. Note that only one message at a time can flow through the network, either from terminal to host or from host to terminal. Let's assume now, as happens rather frequently, that a second printer of a different type, a line printer for example, has been installed in the same general location for the same user application. Frequently, the two types of terminals will require different controls, so that separate communication lines must be installed and the application program modified. The action is the same as before, except that messages flow independently from both terminals to the host and back through their own communication line. But since there are now two lines, line costs are up. And with a bigger, more complex application program, programming costs are also up. In multiple applications, it's the same thing. More lines and more terminals, since terminals assigned to one application cannot be used for another, and costs go up further. And finally, as a communications network grows more complex, the possibility of a breakdown grows with it. If a single communication line goes down, the affected terminals become essentially useless. If the multiplexer or the host goes down, all terminals become unavailable. Manual backup or duplication of facilities offer a solution, but once again, costs go up. In this kind of environment, users find it difficult to install applications, to take advantage of new terminals, or to speed application development. It's either too complex or too expensive. Device control is common across various terminals, which reduces application program responsibilities and helps to lower programming costs. Line control is now processed in the communications controller, thus freeing the CPU for other tasks. Other advantages of the new system become apparent when two different terminal types are installed for the same application. Since the controls are now the same, and control actions are now handled in the same way, line costs can be minimized by multi-dropping the two terminals from the same communication line. Adding applications does not necessarily mean adding line costs, since lines are no longer assigned by application. Nor does it necessarily mean adding terminal costs, since the same terminal can be used for multiple applications. The new line discipline also permits messages to flow over a common line from one terminal to the CPU at the same time that return messages are being sent to another terminal, a more efficient use of communication facilities.